Guess I'm all ready. There we go.
Okay, so part B. So what's our new parent equation going to be?
A equals 1/2 xy.
Okay, good. So we're looking now for A. So we want to know A dot equals what? There's all our parent stuff up here, or all our snapshot stuff. Parent equation, A equals 1/2 xy. Good. And so, yeah, when we do the calculus, we're just implicitly differentiating, right?
Yeah.
So that's going to give me an A dot. Now, what do I have to, over here, I got to be a little bit careful, Ron.
Chain rule.
Okay, good. I got 1/2 times. What's the product rule of x times y going to be if we're differentiating with respect to t?
X, y dot.
Okay, good. X,
Plus
y dot.
Y, x dot.
Good. Right?
That
Makes
is what
sense?
I got.
And we have all that stuff, don't we? Right? So that's just a matter of plugging in some numbers. In fact, let's not even do that. Let's, in the interest of time, let's just kind of, there it is. We could do that if we really wanted to. Okay, now part C.
I really want to.
Find the rate at which the angle between the ladder and the wall of the house is changing. Okay, so now let's, okay, yeah, we'd have to, we want to, we know lots of stuff here, right? We know x and y, and we know the length of this thing.
So we're trying to find
Right, right, so we're trying to find, we'll call this theta, how about, right? So we want to find the rate at which, by the, oh no, I'm sorry, that's the wrong one, isn't it? Formed by the side of the house, you got the wrong theta.
Oh. Seriously.
They want this one, don't they? Does that make sense? The angle formed by the side of the house and the ladder. Those will be the sides of the angle, right? Okay. Okay, so then, now we can do this any number of ways, but what's probably the way that we would choose to do this? We might as well make this as easy as possible. Do I want to involve both the variables x and y?
No.
Don't need to, do I?
No.
I really don't need to, right? Does that make sense?
Yeah.
I might as well pick an angle where I can just, you know, because I know what the hypotenuse is of that triangle.
Mhm.
It's constant. So we could use like sine, for example, okay?
Like sine.
So we could use our parent equation to be sine theta. And the other thing about that is the derivative of sine is pretty simple, right?
Yeah. Just go sine.
Okay, so sine theta equals x over 20, yeah, that makes sense, x over 25. And we also get the variable on this side in the top. That's another good thing, right? Now, if we had used, like, for example, tangent, it's going to work, but tangent's going to give me x over y, and so I'm going to have to do a quotient rule over here. I mean, you know, wouldn't we rather not do that?
Yeah, I don't like that.
Okay? So this ends up being probably not too bad, huh? If we differentiate this implicitly with respect to t, what do I get on the left side? Cosine theta, right? Because I have to use
Theta
chain rule,
dot.
don't I? I got the derivative of sine hand is just cosine hand.
Yeah.
Okay.
I'm saying theta dot, yeah.
Times
Theta dot.
theta dot, and that's what we're looking for, equals, what's the derivative of x over 25? Do I need quotient rule?
No.
No, no, because 25 on the bottom is the same as multiplying by the constant 1/25, right? So what's that one going to be? Well, we're differentiating with respect to t.
X dot.
Yeah, so just x dot over 25 or 1/25 x dot, either way. Okay, does that make sense? Okay, now here's the thing I really wanted to get to in this. This is a great trick, and this is, trig is a big deal. I mean, we use trig a ton in the math of the real world. I mean, angles are a big part of life. So when you're dealing with angles like this, now when we isolate theta dot, right, to solve for theta dot equals x dot over 25 cosine theta. Does that make sense? Just divide both sides by cosine theta. Okay, now how am I going to solve for, I know x dot, how am I going to solve for theta dot? Or for cosine theta, sorry. I mean, that would mean I would have to go back, I got a couple choices, right? I could go back and I could actually add theta to my snapshot variables, couldn't I? Because if I know the sides of a triangle in my snapshot, I can go back and use an inverse trig function to find the angle, right? Does that make sense? So for example, I could say that if I wanted to solve for theta at this snapshot, at this one frame of the movie, I could say sine theta equals 7, I think that was?
Yeah.
7 over 25, put it in my calculator, and turn that into an angle, right? Does that make sense?
Good.
Okay, and then I could take the cosine of that angle, right? Okay, does that seem a little bit redundant to you to use inverse trig to find the angle and then turn around and take the cosine of that angle?
Yes.
Doesn't it?
Yeah, I'm like, what?
Doesn't that seem a little bit redundant? Because it is. It's really redundant. When you are using a right triangle and you know or can calculate the side lengths, it's always a good idea to think of that as a reference triangle, meaning you can write all of the 6 trig functions as ratios, right? That's what they mean in terms of the triangle. So why would we go through the hassle of even bothering to find out what this angle is when cosine theta is a ratio that we know real easily, right? The ratio cosine theta in our triangle is what? Yeah, it's gonna, well, cosine of is gonna be which one? Cosine is adjacent, so it's gonna be this one, and wasn't that 24? So 24 over 25, right? Easy. Okay, make sense?
Yeah.
That'll come up a lot this
Okay,
year,
yeah,
so
I was
use
like,
reference
what?
triangles whenever you can. So then this is just equal to, if I plug in the values, wasn't that negative 2 over 25 times,
Yeah. It's just 2.
oh, positive 2? Yeah, that's right, it's
Yeah.
positive 2, yeah, you're right. Exactly, so it's just 24 on the bottom, so it's 112, right? That's theta dot. Now, okay, theta dot is, what does that mean? There's the last part of this that's I think pretty important. Theta dot equals 1/12 what? Well, what do we measure an angle? I mean, that's an angle, right? Notice that if I were to put the units in this thing, I would have gotten, think how these units would have worked out. I would have had feet per second, and if I add these things, I would have had feet per second over 25 feet. So the feet would have canceled. The cosine theta would have been unitless, right?
Yeah.
Doesn't that make sense? Because cosine is a measure of feet over feet, right? Does that make sense, that ratio?
Yeah.
Angles are,
Yeah.
so my final answer ends up being 1/12, and if I were to keep track of the units, they're just per seconds. So how do I interpret that? What is the 1/12, I mean, in what sort of, and units are really a bad word here, but in what angle measurements? Would it think it'd be degrees? It's gotta be radians, yeah. And remember why. It's been a while since we talked about this, we haven't done a lot of trig yet. But degrees are arbitrary, right? Degrees could be anything. I mean, we just arbitrarily picked 360,
That's
right?
right. Yes, our entire childhood was a lie. That's right.
Yeah,
I remember.
yes, that's right.
I remember.
But radians mean something, right? Radians really are the measure of the distance around a unit circle, and so that's really is why radians, inevitably are gonna be this answer, because that's, they have some real mathematical meaning, whereas degrees are just a big lie, yeah. Sorry to burst your bubble.
I just want to let you know, I'm gonna tell you labs are really good used for testing.
Heart
Fifth,
degrees.
sixth, and seventh, to apply.
Oh, nice.
Absolutely.
Thank you, I really appreciate that.
I'll make it.
5,600 names.
So, 6 and 7, 6, 2, 5. Okay, I can work around that, yeah.
Fisher's in there.
No, dude, no, it's 60 because it was the whole.
She has them.
Yeah, I know.
Oh, that's fine. That's good.
Yeah, one, yeah.
Like 0.
Thank
How
you,
about
Sherry.
like?
Thank you,
1,000?
appreciate it. Okay, so, does that make sense? We good with that?
Yes, it does.
Okay, very good. All right, so now, do we have time? How are we doing here?
3 minutes.
Trace minutos.
We need like 2-hour calculus classes. Then we can take a little extra time every day and talk about
Yeah, 'cause then we can
doppelgangers
play
and
some
the
more.
universe and whatnot.
More time in the lab?
After about an
I
hour,
like
you
more
start
time in the
to
lab.
put us down,